This is a demonstration video that will try to explain what VLANs are all about for you. VLAN is a virtual local area network. Basically, it is a subnet on your network. Now, prior to this, you've been able to make switches communicate on the network without anything special going on. Now what we're going to do is we're going to logically segment our network out so we can keep traffic isolated a little better. The example the curriculum gives you is we can have our faculty on one subnet of our network, students on another, and then maybe have a guest segment of our network, all separate subnets and all isolated from each other. So if somebody in the student VLAN was to fire up Wireshark and start capturing network traffic, they will not see anything going among the faculty. All the students will see is traffic going across the student VLAN. That's one of the security benefits that you get out of these VLANs. With VLANs, if you don't have a router to route from one VLAN to another, you're not going to be able to communicate between subnets. So what we mean by that is without this router properly configured to forward traffic from one subnet to another, faculty will never talk to students, students won't be able to get to guests, and so on. If there's no router, there's no inter-VLAN communication. As soon as you add a router and configure it with the routing protocol, then we can communicate among our VLANs. The main things that we get out of having VLANs are improved network performance. Broadcasts in particular, someone sends out a broadcast, everyone on the network has to hear it. If we put people in subnets and isolate those VLANs, now suddenly only the people in that subnet, in that VLAN, have to hear that broadcast. So instead of all 3,000 computers on campus having to listen to a broadcast, now you're down to maybe all 400 in your subnet have to hear it. If something happens, we run into a broadcast storm, meaning that something's gone wrong, we've got a network card that's failing, sending out an endless broadcast, it'll be isolated to that subnet, to that VLAN, and not take down the whole network. And then as far as the security goes, because you can't see what's going on other VLANs, you can't use Wireshark to capture that information, you've got extra security as a result. As far as VLAN numbers go, generally speaking, you're going to see numbers 1 through 1005 are the common VLAN numbers that you can use. When we talk VLAN numbers, they are literally just numbers that are used to identify this virtual local area network. So if we've got a 192.168.1.0 subnet that we're going to put on our network, we might call that VLAN 1. We might call it VLAN 2, VLAN 1000. Does not matter what number we assign to it. Alright, when you configure your switches, up till now we've just been plugging our devices in and going, but we're going to have to add some new terminology. The interfaces that you plug your end user devices into, like your PCs, your servers, your printers, those are going to be plugged into what are called access ports. We are literally going to go to the switch, configure the interface to be an access port. The interfaces that our switches plug into to connect to each other, we're going to go to those interfaces and configure them as trunk ports. Trunk ports carry traffic between switches. Access ports carry your traffic from your end user devices to the switch. As far as VLANs go, there's a few important ones to kind of get a handle on here. VLAN 1 is the first one. It's the default on all Cisco switches. You can't name it, you can't delete it, you can't do anything with it. A lot of traffic on a Cisco network runs across VLAN 1. There we go. It's a commonly used VLAN. The default VLAN is the VLAN that when you plug all of your PCs into your switch, that's the VLAN that your devices belong to. And by default, it's going to be VLAN 1, but you can change that to be whatever you want. There's a management VLAN. On some of the packet tracer activities, you might have seen this popping up, where you have to type in interface VLAN, say 99 or something like that, give it an IP address, no shutdown. Well, that is configuring a management VLAN. Now you can telnet or SSH to that IP address. That IP address is physically on the switch. It is a management level type device. So as I mentioned, access ports are the ports that you plug your computers into, your printers into. You go to the switch and you configure those switch ports to be access ports, and you assign them to a VLAN. VLAN 1, VLAN 50, VLAN 10, 20, 30, whatever you'd like. You don't have to put an IP address on your switch ports. That's not how this works. The IP address goes on the computer, the switch gets assigned to VLAN for that port. That's all the communication that's necessary to make this work. Trunk ports. Trunk ports carry the traffic from one switch to another. They don't belong to a specific VLAN. There is no VLAN assignment on this. The most commonly used protocol to carry traffic from switch to switch is 802.1q, IEEE 802.1q, sometimes called .1q. If you didn't have trunk links to get your traffic from one switch to another, you would have to have one access port for each VLAN on your network. So in this case, we've got three VLANs, 3 subnets. You'd have to have 3 of those. There's a 4th one in there for other reasons as well. Because you have trunk links, you're going to be able to configure the switch interface on both sides of this trunk link to carry all VLAN traffic. All VLAN traffic goes across, communication works just fine. Alright, as I mentioned at the beginning, communication is limited to being within a VLAN unless you throw a router into the mix. If you want to communicate from one VLAN to another, you have to have a router or some sort of routing component in place. The protocol that's used to carry the traffic from one switch to another, I mentioned that it's 802.1q protocol, sometimes known as frame tagging. And the reason why it's called frame tagging is because if you take a look at this original Ethernet frame that a computer might send out, what we do with frame tagging, or .1q, is we insert a tag. That tag is basically the VLAN number. And then we recalculate the frame check sequence and send that on to the recipient. Okay, this goes from switch to switch. The switches need to know this information. End user devices like your PCs don't. Your PCs never know what VLAN they belong to. Instead, they just get configured with an IP address, subnet mask, default gateway, and they communicate on the network. The switches add the VLAN identifiers as needed. So, while Ethernet frames used to range from 64 to 1,518 bytes, this extra 4-byte tag is now going to make the maximum size for your VLAN, for your Ethernet frames. Maximum size is going to be 1,522 bytes. Alright. In addition, because our switches have to take this frame, strip off the frame check sequence, put in a tag, recalculate a frame check sequence, we're not going to be able to do any sort of cut-through switching or anything like that. We're going to have to do store and forward. Take in that whole Ethernet frame, do what we need to do with it, and then send it on. Alright. Native VLAN is used to identify any traffic that's going from one switch to another that hasn't been tagged, that no switch for whatever reason has put in a VLAN identifier. Important thing to note, when you configure switching, when you configure communication between switches, both sides of the trunk link have to have the same native VLAN. Which one is it? Whatever you want it to be. VLAN 50, VLAN 1000, VLAN 2. It doesn't matter, just as long as it's the same throughout your network. Alright, now to get to something that's a little unsafe to use in most circumstances, and that's Cisco's proprietary dynamic trunking protocol, DTP. Don't use it in the real world. It does have its uses, its benefits, but for security reasons, there's just too much downside to this. Basically, you configure dynamic trunking protocol on every interface, and then the switch will use DTP to figure out whether we need to be a trunk link or an access port. Well, if you're doing good network administration, you don't leave stuff like that to chance. When you configure DTP on your switches, generally speaking, you are just going to configure DTP to be off. Okay, you might, on your trunk interfaces, just turn them on to be trunk configurations. I show you that elsewhere in the course material. But you also have the ability to try to force an interface to be a trunk interface, or let the other side tell you whether you should be a trunk or not. Again, it's all leaving things to chance. I cannot recommend Cisco's dynamic trunking protocol just because you need to know what's on the other side of your network. As far as VLAN attacks go, there's a couple well-known attacks: switch spoofing and VLAN double-tagging. The switch spoofing idea relies on DTP. Basically, what you do is you take a switch, you plug it into the network you want to attack, and if the network administrator on that network has decided to use DTP, there's a pretty good chance that your switch will tell their switch, hey, let's be a trunk port. Why do we care? Because remember, trunk ports carry traffic from all VLANs. So that means that all the traffic that goes through the switch is likely to go across that trunk port that goes directly to your rogue switch. Not a whole lot to it. Free software will set that up. How do you prevent that? Here you go. Actually a little incomplete here. On the trunking side, you go to your interface that you want to have be a trunk. You type switch port mode trunk, switch port no negotiate. DTP is now off. And then you do the rest of your trunk configuration. On the access port side of things, you have a PC connecting to your switch, switch port mode access on that interface, and then I would also do a switch port no negotiate. It's not necessary. It's not necessary down here either, but it's very precise. Now DTP will completely be turned off, which is really what you want to have happen. The other option here for an attack is VLAN double-tagging. In VLAN double-tagging, the attacker creates an Ethernet frame with basically two VLAN identifiers on it. The switch receives one VLAN identifier, strips it off, but the other one's already there, forwards it on. All sorts of problems pop up. This one, I've got some steps here in the slides that show how this works. I'm not going to go through them because Cisco switches by default now do not allow a double tagging attack to work. And that's one of the nice things about using a Cisco switch at this point, is they do have the extra security in place. Again, how do you prevent it? Disable DTP, make sure your iOS updates are applied on your switches, and that's about all you need to do to prevent VLAN double tagging.